Hello, this is the lecture number 11 for the chapter Application of Derivative for class 12th. And we are starting with the topic Maxima and Minima. A point C in the domain of a function f at which either first derivative of the function at C is equal to 0 or f is not differentiable is called the critical point of the function f. The critical point of the function f is that point when we put first derivative of the function equal to 0. Now, what is the first derivative test to find the local maxima and minima of the given function? Let f be a function defined on a open interval I. Let f be the continuous at the critical point C in the given interval I. Then, if f dash x changes sign from positive to negative as x is increases through C, that is the first derivative of the function is greater than 0 at every point close and to the left of C. That is, if we change the value of x from the smaller value of C and if first derivative greater than 0 and the sign of the first derivative changes from positive to negative as the value of x or a point changes from left to right or from the smaller value than C to the greater value of C, then C is the point of local maxima. That is, if the sign of first derivative changes from positive to negative as we change the value of x from the left of C to the right of C, then C is called the local maxima. Similarly, if first derivative of the function changes its sign from negative to positive as x increases through C, that is, if first derivative of the function is less than 0 at every point close to and to the left of C, and first derivative is greater than 0 at every point close to the right of C, then C is called the point of local minima. That is, if the sign of the first derivative changes from negative to positive as x increases from left of C to the right of C, then C is known as the point of local minima. Now, if the first derivative of the function does not change its sign as x increases through C, then C is neither a point of local maxima or a point of local minima. In fact, such point is known as the point of inflection. Now, this is the first derivative test to find whether the function have local maxima or local minima. If the first derivative sign changes from positive to negative, then it will have local maxima. If the sign of the first derivative changes from negative to positive, then it will have the point of local minima. Now, then we also have a second derivative test to check the maxima and minima of the given function. Let f be a function defined on an interval I and let any point C belongs to the interval, then f be twice differentiable at C, then at x equal to C is a point of local maxima if first derivative of the function at C equal to 0 and its second derivative at C is less than 0. That is, the second derivative should be negative. Then at C we call that a function have a local maxima and the value of the function at C is known as the local maximum value. Now, if x equal to C is the point of local maxima if its first derivative at C is 0 and its first derivative at C is greater than 0 or positive, then the value fc is called the local minimum value at C. If its first derivative, if we put first derivative equal to 0 and find the value C, the critical point, and if second derivative at C is positive, then we have the local minima and fc is called the local minimum value. Now, this test fails if first derivative equal to 0 and the second derivative is also 0 at point C. Then we use the first derivative test to check the maximum minima as we have done in the starting of this lecture. Now absolute maxima and absolute minima, how you find it? Now find all the critical point of the function f in the interval, that is the point x where either first derivative of the function x is equal to 0 or f is not differentiable. Then take the end point of the interval, whatever the interval is given, and at all these points calculate the value of the function f, identify the maximum and the minimum value of the function f, out of which the values of x, the maximum value will give the absolute maximum value of the function and the minimum value will give the absolute minimum value of the given function. So there are two tests to check maximum and minimum of the given function. The first derivative test, we have discussed that if the sign of the first derivative changes from positive to negative, then we have local maxima. If the sign of the first derivative changes from negative to positive, then we have local minima. And in the second derivative test, if the second derivative is negative, then we have local maxima, and if second derivative is positive, then we have local minima. This is the first derivative test and the second derivative test to find whether the given function have maxima or minima. Now we are starting with the exercise 6.5, in which in the question number 1 you have to find without using the derivative to find its maximum or minimum value of the function. Now in question number 1, first part, fx is equal to 2x minus 1 whole square plus 3 is greater than equal to 3 for all real number. Why it should be greater than equal to 3? Because the perfect square cannot be negative. It cannot be negative. Its minimum value will be 0. Its minimum value will be 0. It cannot be less than 0. So 0 plus 3. So it means its minimum value will be 3. Its minimum value will be 3 for all real numbers, whatever is the value of x, or x belongs to real number. So the minimum value of this function is 3. When it will equal to 3, when you replace x by 1 upon 2, so then it will be equal to 0, and 0 plus 3 is 3. Now this function has no maximum value, because as the value of x increases to infinity, the value of this function 2x plus 1 whole square plus 3 increases up to infinity. So this function have only minima at x is equal to 1 upon 2, and minimum value is 3, and this function has no maxima, because as we increase the value of the x up to infinity, the value of the function goes up to infinity. So this function has no maxima. Now let us take this function fx is equal to 9x square plus 12x plus 9. First of all, make it a perfect square. First of all, make it a perfect square. You know how to make a perfect square. Take 9 common, then adding and subtracting the square of half of the coefficient of x. You know how to make a perfect square. This comes out to be this. Now see this function and compare it with this. We have plus here, we have minus here. Now the minimum value of this perfect square again is 0. It cannot be less than 0. And 0 minus 2, it means its minimum value will be minus 2. So the minima of this function is minus 2, because this perfect square cannot be less than 0. So 0 minus 2, minus 2. So its minimum value will be minus 2. Now, when it will be minus 2, when the value of x will be equal to minus 2 upon 3, then it will become 0. So 0 minus 2, its minimum value is minus 2. Now what about the maximum value? Now as we go on increasing the value of x, the value of this perfect square, whole square, will goes on increasing, and as x goes to infinity, the value of this function goes to infinity. So therefore this function have no maxima or no maximum value. As x goes to infinity, the value of this function goes to infinity. So this function does not have maxima or maximum value. Let us take the third part, fx is equal to 10 minus x minus 1 whole square. Now the value of this function, now this value cannot be negative again. X minus whole square cannot be negative. So its minimum value is 0. So 10 minus 0 is 10. So the value of this function is less than equal to 10. It cannot be more than 10 because this value, its maximum value here will be 0. X minus 1 whole square, the maximum value of this 0, and because we have the negative sign here, so 10 minus 0, so less than equal to 10, so its maximum value will be 10 when x is equal to 1. Its maximum value will be 10 when x is equal to 1, because it cannot be more than 10, because as the value of x goes on increasing, this negative sign goes on increasing and it will have no minimum value. As the x goes to infinity, the value of the function goes to minus infinity. The value, as the value of this function term x minus whole square goes on increasing, this will become negative and negative and negative and so on. So it will have no minimum value or no minima. Now in the fourth part of this question, fx is equal to x cube plus 1, because we don't have the perfect square here, we cannot make it a perfect square. Now as the value of x goes to infinity, goes on increasing up to infinity, the value of this function x cube plus 1 also goes on increasing and increasing up to infinity. So it will have no maximum value. Similarly, as it goes on decreasing the value of x up to minus infinity, the value of this function also goes up to minus infinity. So therefore this function have neither maxima nor minima. So similarly is the question number 2. Like this we can do. Now fx is equal to mod x plus 2 minus 1. Now the value of this mod cannot be less than less than 0. Modulus sign make the value of the function positive, so this its minimum value is 0. So mod x plus 2 0, minimum value minus 1. So 0 minus 1 is minus 1. So its minimum value is minus 1. It cannot be less than minus 1. So it will have minima at x is equal to minus 2, which is equal to minus 2. When x is equal to minus 2, the value of this function will be 0 and minus 1. So its minimum value will be minus 1 when x is equal to minus 2. Now as the value of x goes on increasing and increasing, the value of this function goes on increasing and increasing. That is, the x goes to infinity, the value of this function goes to infinity. So this function has no maxima. Now the question is totally different from this. We have a negative sign here and the positive sign here. Then the maximum value of this mod x plus 1 will be 0. It cannot be more than 0 because we have a negative sign here. So 0 plus 3 is 3, means less than equal to 3. It cannot be more than 3. So the maximum value of this function is 3. See the comparison between these two parts. Now as the value of x goes on increasing and increasing up to infinity, then this term goes on up to minus infinity. So this function does not have its minimum value. Now the third part, we have hx is equal to sine 2x plus 5. Now we know that the value of sine is from minus 1 to 1. From minus 1 to 1. And if we add 5 to both sides, so its minimum value will be 4 and maximum value will be 6 of this function sine 2x plus 5, because the maximum value of sine is 1 and minimum value of sine is minus 1, and because 5 is added to this term, so if we add 5 to its minimum and maximum value, so its minimum value will be 4 and maximum value will be 6. Now in fifth part of this question, hx is equal to x plus 1, and it is given that the value of x is from greater than minus 1 and less than 1. So it is the given condition is there. Now because we have the function x plus 1, to add 1 on all sides. So minus 1 plus 1 less than x plus 1 less than 1 plus 1, adding 1 2. That means x plus 1 greater than 0 and less than 2. So the value of this function x plus 1 is greater than 0 and less than 2. That is no maxima, no minima. We have infinite terms from between 0 to 2. Therefore, it will have no maxima or minima. Okay, we'll discuss the next question in the next lecture. Thank you.